we can start with our next topic. So now that you are all experts in REST services by now, you will start to work and implementing the REST services. In the meantime, we will go ahead with the content, and we will start in our frontal lectures to talk about the so-called big web services, or in a simple way, they are called also SOAP services, mentioning the first layer of standards that is used for the messaging, which is the SOAP. And so that at the end of these other couple of lectures, I think we will be able to to compare the two approaches to see what are good things and what are bad things about these kind of projects. I'm feeling some feedback on this one, which is not good. So we are here in the stack. You might remember this one. It will be with us for other times. And we are now talking in this lecture about the messaging part. And you might remember that the set of problems to be solved in general by distributed system, and in particular by web services, are the following. And the messaging part tackles this part, which is the exchange of data between machines. It's an old problem, and the way that the SOAP services are solving it is very, let's say, not particularly new one, is not innovative, but it is a very practical one and has been very successful, and it's the base of the stack. This is a very brief recap because you have already mentioned this one when we started to talk about REST services. And the first attempt to solve this problem has been through the so-called XML-RPC, which is to wrap essentially in a very, let's say, simple way, is to wrap the call to remote services in an XML format, and using standard HTTP protocol. As you know by now, this is the way that the REST movement, or at least RESTful services framework started and went over. This is the preliminary stage, just wrapping RPC, remote procedure call, in XML, and then it went on with a more, let's say, complete and reliable framework. But that's the beginning, and it dates back to about end of the 1990s, so 98. So in parallel to this thread, which brought to us the so-called RESTful services, another protocol was introduced by W3C, which was called Simple Object Access Protocol, and the acronym of this one is SOAP. And so we are talking now about this protocol. What is SOAP is, again, a protocol for transferring data. So it essentially makes another layer on top of a number of layers. In our case, typically is TPC IP stack and other kind of transfer protocol like HTTP, in order to be able to send messages and interpret messages on the other hand, and back and forth. On top, there are the web services with their interfaces, but at the moment we will concentrate on this particular layer. So SOAP, you can say, is the heart of the web service architecture because it enables the communication. A little bit of data about, or information about the protocol has been introduced in 1999, so essentially 1 year later from the first attempts of the XML-RPC, but we are essentially in the same period. At the moment, the current version is 1.2, so it's not evolved very much. I mean, if you see all these numbers, if they changed very often, it means that they are really doing a lot of changes. In place, SOAP was, let's say, got right in the first place, and the first version was 1.1, strangely enough, not 1.0, and it only evolved 1.2. So essentially, it was a protocol that worked well from the beginning, and it is now widely used. What is it? It's a lightweight protocol. It's not very complicated, intended for exchanging structured information, and it uses XML technologies. That is the main point of the definition. You find this definition if you go and see at the definition of SOAP at the W3C. I think this is not working very well, huh? At least I have some feedback back, so let me try to do something about it. But I don't know. We will have to live with this noise, essentially. SOAP protocol, or essentially covers, fundamentally, it tells how is the message between the two services to be formatted. And so that's the main part. Then it has some other extra information. It gives you also a description of how the SOAP message will be transported. So it gives you a range, we will see, of opportunities on how to transport this message. And then there is rules for processing the messages, convention about the interaction styles. We will cover all of them, but in particular we will manage, I want to go into a little bit more detail with you in this lecture on the message format, and then we'll cover a little bit of the other stuff which are in the protocol. Obviously, you are very welcome to look at the protocol as described by the W3 consortium, and you have all the information there about the protocol. But what I would like with these lectures is to give you the main ideas and concepts behind this protocol, how it is used, and the peculiarities, what makes it particular and interesting for us in the web services. In particular, how does it compare with, for instance, REST kind of services, exchange of data, which is, as you know, a structured XML document. Just by remaining on this slide, luckily enough, it will be very difficult that you have ever the chance to actually write the SOAP message. Luckily enough, there are some nice SOAP servers that are doing this for you. So you as programmer, or we as programmer, we are going just to write our services and define what we want to send as a message, and then it is a automatic machinery of the middleware that takes these parameters, writes the proper SOAP messages, sends it to the other web service, which is interpreted and used, and vice versa. But it's always good to know the things that you are using, because that's, you know, also the limitation of these systems and what it is good for. So that is the idea that I just introduced, and that is that essentially what we are talking about is the fact that wherever there is a web service application running on some kind of provider, it relies on a SOAP server on the side of the service and on a kind of, let's say, SOAP infrastructure on the kind of the client. So the obvious communication, it has a number of steps, and your application who is requesting an operation to be done, some information to be obtained by an external service, web service, sends this request to a SOAP message constructor, essentially, which is an XML document, as we will see. This message is binded together with a particular protocol, network transport protocol. In this case is HTTP, but as we will see, it could be also a different protocol. It travels on the net as usual, on the internet, in this case. And on the other side, there is another server, SOAP server, so a middleware component that is capable of translating these messages, and it translated in the actual and implementation infrastructure of the web services. So that is a simple solution, very standard in all these message exchange. You have been heard about marshalling and unmarshalling of data. Each particular distributed system has its own application. Also, the REST services have its own application, which is this XML document which arrives and it's interpreted on the other side. So what is new about SOAP messages? The new things, we go back on this one, is essentially mainly two, essentially, from what you have met before. One is not a novelty. Novelty number 0, in some sense. It is an XML document, so also REST services uses XML documents, so no problem about that. So that's why it's not a big deal. Differently from REST services, SOAP messages, they have a schema, and we will see about that. So it has to be not only a well-formed XML file, but it has to be validated. And this makes it more, let's say, reliable. So in particular, it makes it more useful for you to use a standard SOAP server that are capable of interpreting these messages. The second novelties is that is not only XML, it has an XML schema, but can be binded with a number of transport protocols. Now, it's not binded only to one particular protocol. REST services or XML-RPC, the initial ancestor of REST services, are binded only to HTTP, while SOAP from the start was able to bind to different type of protocols. We will go back on that one, but that is, I wanted just to give you in a nutshell the new things. So that's just various example. For instance, so if it works, if you also number of application, in particular Google, allows you to ask the service both as a web application that we all know through the Google website or through a web service interface. The difference is that in this way you can, for instance, embed your search in your own program if you are interested, or you can embed the search of Google, as it is often done, in your web application by using this kind of interface. It's clear that in this way it can be also abused in the sense that you can write programs that are sending search requests at a very high rate, and obviously you will be detected and banned. So there are some rules of usage of this kind of automatic or API. These API which are clearly for usage of a computer. But they look like this, so that's what you can expect, is a kind of XML file. So this is an example of a SOAP request to search that particular sequence of words, and it goes like with a standard XML file, and this is the result. So it's very long. It contains all the information which is processable by machines. And This is just want to be just an example on how it looks like. Now let's go in to see a little bit in more details what it is made of. And let's go to see in particular how it is organized, the SOAP message format. This is interesting because it is very well used. It's a good protocol, so it will probably also be based as a good design practice if you want to see. So the SOAP messages are standard and are very simple. They are XML documents which have essentially two components, a header, and you can have many header blocks inside, and a body. And you have many body block inside. The application payload, which means the important information that you want to carry, are in the body, while the header, usually additional protocols, other kind of issues like security transaction, can be put in the header. But as we will see, the SOAP protocol has been mainly used without not a lot of overload of things. So usually it has a very light header, and the majority of the things are in the body. That is, you're just transferring data. And additional protocols are pushed in upper level of the stack of the services. So very simple in this case. We will see that other protocols like WSDL are a little bit more complicated. And this is something that I've already said. The header is intended, but here it says some more information, as a generic placeholder for information that is not necessarily application dependent, and typically is used for coordination information and like transaction or security information. And it also gives the role of the various nodes that are going to intercept and read these messages, and they assign some roles of these nodes, essentially. If they have to do nothing, if they have just to pass it to the next node, or if they are really the ultimate receiver of this message. But we are not going to go too much into detail into the header, because in reality is not used too much, okay? What we are going mainly to use the SOAP message is to transfer the data, and so we are very interested in the body. And the body is, while the header does not need to be present, the body needs to be present, otherwise you don't have anything else. So it is important. There are essentially only two possible data inside this element. Your message, the application-specific data, or it's also a good way, is also the way to put error messages or fault messages inside the envelope. So it is used for either application-specific data or application-specific error data that you need to communicate between typically the server and the client, but sometimes also between the client and the server. So that's how it looks like now in a more simple way. You have the envelope, and in this case there is a very simple headers, and then some generic information, and then there is the body. In this case it's essentially body only. So you can already, looking at this example, get what kind of SOAP message you can have. This is not the only kind, but it's one possible kind. And this is the kind that looks very similar to a remote procedure call. So you have essentially what we humans can interpret as a request of something, very similar to a request of an operation. And then you have some information about the parameters that you are requesting. In this case, we can more or less simply understand that it is something that has to do with a stock market, the price of a particular symbol in the stock market. Two things in the headers. The information about a specific schema. XML schema. So it's not like in REST that you do your own schema and you then decide whatever you want, how you want to transport your data. But in this case, the schema is fixed and has to be, can be, let's say, doesn't have, but can be validated in the envelope. And then there is another important thing that we will go through, which is the encoding. So there is another schema which tells to the server or to the client how to interpret the data, okay? So that's the trick about the exchange of this data. You're using XML files, but you're using a specific schema on the structure of this XML file. And then you can also use, in this case, a specific schema that tells what kind of, how to interpret the data that you are sending. And we will go back on this one because the encoding is the core part of the SOAP protocol. And that's a typical response. So again, in the response, you have information about the schema, information about the encoding schema, and then you have something which is a result of this particular. So this is the answer. In the previous one, we were asking the price of something which is DIS. I don't know what is this symbol. Could be any symbol in the stock market, and this is the current price. So as you can see, this is a simple example of a remote procedure call. I'm calling, and then I get back the response. Encoding. The encoding style, which I recall you is this particular tag here, which refers to a schema specific for the encoding, conveys the information about how to interpret the contents, how you will do that one. Why you need this one also in XML? Because you can have different ways of putting your information inside. This is a very, let's say, complete way. This is a shortcut in which essentially you are using the balance as an attribute. And you have to tell the actors involved how to interpret this data. And how you do that, you have essentially a shared schema between the client and the server. There is one which is given together with the SOAP protocol, so you can follow the SOAP encoding schema, and this is enough for all purposes. And it's a set of built-in rules for encoding data types. There are different values. There are these two versions, 1.1 and 1.2. And it's very simple. So you are not sharing complex data like hash table or collection. You are able to share scalar types and compound types, and these are very standard. You can imagine, and you are imagining right, the scalar types are a standard way of sharing the simple data type, starting from string, boolean, float, double, integer, etc. So this is the kind, and also some information about unsigned and other date and time typically. So in this way, you can share data among machines which have different data interpretation or data schema. So Java and Windows, for instance, the client can be Java and the server can be Windows or Unix. And you can use the SOAP encoding. The only compound types, which is a little bit more complex data types that you can have with standard SOAP encoding are the arrays. So a list, essentially an array, a vector of the same type. So in this case, you have an array of 2, which has to be explicitly mentioned. The type is a double, and it's an array of 2 position, and then you have the actual data of the type. So scalar types, arrays, and the other and last data that you can exchange are structures, which are, as you know, similarly to what we know in our normal languages, arrays, but of different types. So you can mix a string with a number, with another string, etc. So that's the standard way using SOAP encoding. If you want to do, there is a second way which has been introduced with the new version of SOAP, which is called literal XML encoding. And essentially, again, it's using the fact that with XML is so flexible, is so extensible, that you don't need to rely on one particular schema. You can provide your own schema of data. So if you want to do something more complicated because you are not happy with the SOAP encoding style, which is provided to do, no problem. You can build your own XML data schema and decide to use that one. So in few words, this is the idea. And this is called literal XML encoding. So this is how it looks, for instance, the same accept of code for structs, right? For something which is an array of different types. And here it's even simpler because you just write your own data. You don't give any specification about the fact that this is an integer, this is clearly a string, etc. But somewhere, which is here, essentially, there is a namespace with a schema. And it is in this schema that you tell how you want to be interpreted this particular number of this particular data. So it is in this schema, product service, that you say that the product is an integer, that the name is a string, and you give the information, the detailed information. Now, either works. SOAP envelope is given for free to you, so you don't have to worry. For the XML literal, you have to provide your own schema, and it's only useful if, I would say, I mean, in this case, is an example that we presented of something that can be done in both, but it's clearly that XML literal is more useful if you have more complex data structure that you want to be more flexible, or just because you want to have more control about the data that you are exchanging. So you put forward your own data schema. Okay, so that's the part that concludes the part about the message. So it's very simple: header, body. You have a way that it's telling the user, which typically is a machine in this case, about how to interpret the data and what are the kind of data that are passing, and that's it, okay? What it is different from REST, I repeat because I told it already, the schema is different. REST does not need to have an XML schema, so it does not need to be validated. And the difference is here. In SOAP, you can bind to different protocols of transport. You are not, let's say, obliged to use only HTTP. How you do that? It's very simple. It's a game of boxes, essentially. Not a Game of Thrones. It's a game of boxes. You put this envelope inside the other protocols, the protocols that you want to use as payload of that particular protocol. So the envelope of SOAP, which has the header and the body, can have the header, must have the body, is put inside, in this case, for instance, an HTTP POST request. Why POST? Because you need space. You cannot have only a limited number. The SOAP envelope can be very big, and so you need really to have more space, and you cannot be limited by the GET, which is only a limited number of characters. And you get back the response as a body of an HTTP response. So this one is for HTTP, and this is how it looks like. Is again wrapping around various boxes. The yellow box is the POST. You might recognize a typical POST request. And inside the POST request, you have the envelope. So very easy, not particularly difficult. And the same for the response. So you have the response that everything has been hopefully gone well in this case, and you get the response. The example is always the one of the trade option. The new thing, which is different, you are not obliged to use only HTTP. You can use different other, let's say, transport protocol. For instance, one which is very popular is the simple mail transfer protocol, the one that is used by mail services. And you can have, you can put your SOAP messages as really the body, the text of a message of a mail. The only thing that the implementation of this protocol requires is some information in the messages about identity of the both of the client and of the servers, but it's very well easily done. The previous one, the one on HTTP, is very, let's say, it supports typically synchronous operation like RPC. You are asking something and then you are waiting to get it back. So it's a quite typical synchronous operation. Obviously, the mail is asynchronous, so you are sending it and then you don't know when, if the user is going to be, the message is going to be received unless you have some other extra protocol, or you don't know when it will be received back, the other messages. So it's an asynchronous one-way transport for SOAP messages. And this is how it looks like. As you can imagine, there is a receiver from, and that's the things that are different that you need to add in the protocol. Essentially, apart from the subject, you have to have a unique identifier of the message ID, which is an identifier of who is sending it, and then unique identifier of the response. So with these two extra information, you can do the message correlations between the client and the server. And then how it looks like. So message binding. Now about the binding, let's go back before going to the SOAP communication model. Is this very powerful, useful? This fact that you have more possibilities about the binding. I mean, these are two, which are the two most used ones, HTTP and mail. You can also think about other protocols, but unlikely there are not many other protocols out there which are so commonly used. Okay, there used to be in the past other protocols. You could think about sending SOAP messages with FTP, or send SOAP messages with Goofer, which is an old protocol. The reality is that the number of transport protocols at the moment are not so many. Okay, there are not so many out there, and the most popular one is HTTP. And it turns out that the majority of the SOAP web services are using HTTP, and that's also one of the arguments of the people using RESTful services that say, if at the end I'm going to use HTTP, why should I need so much a big infrastructure on top of it? So, having said that, it really depends on your application. And SOAP-based web services are more flexible, for sure, than REST, because they can, for instance, do this. They can bind with different protocols. You can offer your services in various modalities, one over HTTP, and if HTTP is not available, you can use SMTP or other ones, okay? Or new ones that will come out later in the future internet. About the 4 steps that I was mentioning, this is the third one, the communication model. This is also quite interesting because essentially it's the way in which the information is can be passed between client and services. And essentially there are 2 communication styles. The remote procedure call, which is essentially the one that I've shown you as an example, a running example now, in which you are requesting a call, a procedure, and then you are waiting for the response. In our example, it's very simple, can be as complex as you can make it, or just as a document communication style. Combined together with the encoding, at the end, the communication styles come in 4 flavors, because you have 2 encoding styles, 2 communication 4, and so that's the 4 ones. So RPC literal or RPC encoded, document literal, document encoded. These are the 4 communication styles. But the main ones are RPC styles and document style. So RPC style is what you can expect. The web service appears as a remote object to the client, so something that you can ask, and the client requests as a method call with a set of parameters, just like a procedure, and the service returns a response containing the return value. This kind of communication model is good for synchronous communication models, and that's widely used in the SOAP web services. That's how it looks like. I mean, I'm not going to go I'm going to go very quick on this one because it's the same example as before. The key point, maybe that's the point, is that essentially the SOAP body, which is here and here, conforms to the RPC-like structure. That is typically a method name or something that is similar to that, and then a set of parameters. In this case, 1, but it could be more. The second one is a little bit more interesting. Let's say interesting in the sense that it opens new way of providing services or building services. What you send is, the body inside the SOAP envelope is free. So it can be as simple as the request of something, or it could be a very long and complicated documents. If you send generic XML data, which are not really method code, but they are a list of information, that is, you're using this way of document style. In the document style, there are all the information that the service, on the other hand, needs very probably to implement a complete business process flow. And in this way, it's the document that is processed very often within an internal workflow, and then after a while, the client receives back the information, the results of this processing, but which is not, maybe could be as simple as, okay, approved, whatever you are asking, or it could be another document with more information about the kind of things that the internal process has provided. And this so opens a new wave of application. And this is, for instance, an example in which you are sending, I think, a purchase order, which is another of the typical examples, running examples that we do in our course. So in place of asking the price of something, you are sending all the information that is needed to buy, to acquire between the client and the server, a particular information. This document is processed. It triggers an internal procedure, maybe with some approval or whatever checkpoints, and then it gets back a document which says, I can provide this one, this purchase order has been processed, it will be delivered, or there are some problems and we cannot deliver this one. So 2 different communication models, both very important because they support a wide variety of potential applications. Well, a few things about, we'll keep this one and give you this one. We say that the envelopes can contain 2 things, application-specific data, and we have seen some examples, or fault data and error data. And there is a number, and that's the previous slides, of encoded error that you can provide. So also the error messages, that's the message that is important apart from knowing in details of this one. Also the errors are encoded in a particular format and they are standardized, okay? So that's the things that you have to get back. And if it happens that you receive an error message, then you go and interpret what is the kind of message that you are receiving. And it gives you information about the error and about some details, what has happened. So, concluding this short lecture, because that's all for now, for today, is I will conclude with a couple of comments. First of all, that just this layer of SOAP messages has at the beginning, so we are talking about 1998, 2000, essentially, has been able to solve some problems of integration of different legacy system or different information silos or information systems. Because the majority of the systems, and you might remember that that's something to remember, that the web services and the service-oriented architectures originally started with this goal in mind, the problem of integrating different information systems, typically enterprise information system. And the SOAP engine alone solves this problem, okay? In particular, if you are inside a particular enterprise. So let's say that you have enterprise. You have seen this diagram again. Database, external application. You don't have the services essentially. Already at that time were not called web services, but were called store procedure interfaces with their interfaces, and they were essentially called that could be done externally by a specific application connected to the enterprise in this way. And the SOAP services essentially adds on the side this idea of one more layer of middleware, which you have an engine that maps the procedure API into an XML. So if you have a particular number of calls with these parameters, you just create the XML wrapper for this store procedure API. It wraps in a transport protocol. In this case, again, is the most used one in any case, is the HTTP protocol, and it sends it to an HTTP website, allowing a real web service interface. So this first layer is of integration of system is achieved just by SOAP. We are still missing the description of the interface, but this is very important only if you want to have your service to be used by, let's say, the whole world, not by your enterprise. If you want only to be used from your own enterprise, for your single enterprise, you don't need a very big, I mean, you know the description, you give it to the client and to the service that wants to use it. This is why I put this one, essentially because this demonstrates how well this kind of SOAP message exchanging protocols fits well with a conventional middleware architecture. It's just one layer that allows you and it's just a natural extension for standard middleware architecture. So it can be put on top of legacy system, of your web server, and etc. Why is a simple protocol? There is this statement from the beginning that says simple object access protocol. You have seen it now, essentially. The structure of the message is not particularly complex. And what is important is that if you are focusing essentially on the body, which is the main part of the SOAP messages, and you are not overloading too much on the headers, this is where the simplicity comes in. Because putting more information on the headers means that also all the way around the transport, and in particular the ultimate receiver that has to interpret this message, has to be in place, has to understand and has to comply to this specific, let's say, rules. But the majority, so it is possible to put it on the SOAP. In the header you have the space to extend SOAP, adding some more features apart from the pure transport of an interpretation of messages. But this is not really the road that the, let's say, web service community has taken. The idea is that to leave the SOAP message clean, so just enough information on the header to understand what is the schema, what is the encoding schema, and nothing else, and to leave everything else on other, let's say, level of the stacks. So in particular, a big number of additional standards are in fact being proposed and added for the missing functionalities. So typically the SOAP messages are at this level, and they only transport payloads, so data, back and forth, whatever that is, remote procedure call or XML well-formed documents. While if you want some other things like eventing, notification, addressing, security, authorization, reliable messaging, etc., then you use a specific other protocols. And at this stage, it's the two entities, the client and the server, that has to comply to this one. So I don't know if I get to you this message, but SOAP has remained quite clean. And so it's only focusing on one specific issue, which is the transport of the message and the interpretation. And it assures that the message arrives with the proper binding at the other ends and back again. While all the other particular functionalities that you might want, that you might really need for your specific application, like if you want reliability of the messages, you want really that the message, you want to know when the message has arrived and if it has arrived, or if you want transactional properties, which are quite, let's say, typical in business application, then you add an extra layer. So that means that the message has to comply to something else, and you have to have a different layer in your middleware. Okay, we stop here for this part. I usually do the two parts separately. First the SOAP, and then the WSDL, which are the two main protocols. And then you will see them in the lab. Questions?
How can I SOAP implement the reliability?
No, SOAP, as a matter of fact, does not implement reliability. What you have to do is to use an external stack, so another protocol that assures the reliability, which is on top of SOAP. So the messages as itself are not reliable, the SOAP messages, meaning that you don't know when they will arrive, okay? That's essentially. If you want something more reliable, then you have to put an extra protocol. It's very similar to the security in HTTP. If you don't need security, you use the standard HTTP. If you need security, you need extensions of HTTP, HTTPS, in order to have the security. That in that case, which is security and not reliability, means that everything is encrypted, right? Reliability, you need to do some extra work, essentially. Other questions? Okay, then we stop here and continue next week then. Thank you.